Hi guys, welcome to COSC330 530 Parallel and Distributed Computing. This unit is all about writing software that runs on multi-processor and multi-core systems that take advantage of their capacity to run tasks in parallel. So this is the Moodle homepage where all of the content will be made available to you. You can see that you've got a series of tiles here. The first tile contains a set of unit resources. These are links to useful bits and pieces that you'll be able to access through the course. The second tile has your assessment tasks listed, and the following tiles have all of the topics. So this course is broken down into 4 modules. First module covers off on multi-process application programming, where you build applications that have multiple executable processes going on. And the second topic walks through the construction of multi-threaded applications. So we have a single process that has multiple lightweight threads of execution through it. And the last 2 topics, we start getting into the more complicated and advanced hardware by looking at distributed computing with the message passing interface. In this module, we'll be using a virtual cluster computer to write software that executes across multiple machines that work together. The final topic looks at using NVIDIA's CUDA, Compute Unified Device Architecture, to program GPUs to do massively parallel tasks. If we take a quick look up here in the home tile, you've got a series of links. The top link is our unit information and assessment overview. If we jump into here, we've got a little bit of a motivating paragraph for our course. You can read through that in your own time. We've got our learning outcomes, which essentially relate to being able to construct parallel and distributed programs on a range of different architectures. We've got our coordinator and contacts. For this unit, I'm the unit coordinator. My email address is mwelch8@une.edu.au, or you can contact me on 67735004. If you have any questions regarding the unit content, please let me know. Otherwise, all other administrative inquiries can go to either the Science and Technology School admin page or to Ask UNE. Now, the prescribed material for the course, we have one prescribed textbook, which is the Advanced Programming in the Unix Environment text. This one will be required for the unit, and the recommended text is the Introduction to Parallel Programming. This covers off the first text covers off, walks you into the first 2 modules, and the final text contains information for the second and third modules. But it's only recommended, so if you can borrow a copy of it from the library or obtain it, borrow a copy from somewhere else, that would be acceptable. Now, our study timetable is up. You can see that we've got a fairly jam-packed programming, starting with going through from module 1 through to 4. You'll notice that each module has an assignment associated with it, and each assignment will be due at the end of the modules. Now, the assignments will be worth 10% each, for COSC330 and for COSC530 they're worth 7%, with the project making up the remainder there. And at the end, you'll have an exam to complete as well. So we've got 11 weeks worth of content, and the last week is a short week to allow you to do some exam study. In this tile, in the unit, in the expectations of staff and students, there's links that cover off on the expectations of staff and student contact. Go through and have a read of that in your own time. It covers off on things such as the expected amount of hours of study and contact with the unit coordinator. We'll finish up with the assessment overview. As I mentioned before, there are 4 assessments for this unit. The first assessment will be due at the end of the first module, which is in about 3 weeks' time, and they're worth 10% each or 7% each, if you depending on which version of the course, whether you're doing 330 or 530. So jumping back to the home page, as I mentioned before, this course has 4 modules. First module is our multi-process application programming module, and you can see that the unit material is already up and available for you to review. You've got both slides and notes. The slides are the ones that I'll use to present in the lectures. The notes are directly the content from the slides, just laid out in a nice scrollable platform there for you to review. If you have any problems viewing those, they're web slides, so they don't require a PDF reader or anything like that. If you have any problems with them, please let me know. Just before we move on, there's a really interesting slide that motivates our study of parallel computing. Really, the reason that we're undertaking this can be summed up by this particular graph. And here we have the number of transistors on our processors graphed in the green over time leading up to 2010. This graph's a little dated, but does show the trend. And in the blue here, you can see the clock speed. So the clock speed essentially maps to the number of operations that can be performed in each second. And you can see that in about sort of the early 2000s, the clock speed plateaued out. It plateaued out at around about 3.5 gigahertz, but the number of transistors on our chips, on our processors, continue to grow. And that's because the processors, modern day processors, are multi-core processors. So the transistors are devoted to processing more operations concurrently rather than doing a single stream of operations very quickly. As such, it's important for us to write software that suits this architecture so that we can make use of all of this hardware that we've been gifted. Up until this time, up until the early 2000s, the work of improving the performance of pieces of software was largely done by the hardware producers, the chip manufacturers. They essentially achieved faster clock speeds, and that allowed software to just simply glide along. We didn't really have to do much to get a performance boost. But in the modern era where clock speeds have plateaued out, it's up to the software developers to squeeze every ounce of performance out of the software, and that's usually going to be done by incorporating parallel execution into our systems. So that slide really sums up the impetus and the requirement that we have to understand how parallel programming and how to write software that can execute on our concurrent platforms. So if you have any questions, please let me know. My contact details are up here on the corner of your Moodle page. And good luck with your trimester 2 studies. Thanks, guys.